Am I audible to you?
Yes, sir.
Yes, sir.
Okay, so now I can see 33 students are there, and from the roll sheet I can find there are 36 students. So 3 are still missing. Anyway, they can join up to 15 minutes. So I'm starting the class. Okay, now one more has joined, so 34 students now. So 2 students missing. So now I am starting the class, and you know that today's laboratory experiment is on. Okay, now it is 35 students. Good. So only one student left. Okay, so now it is the determination of breakdown strength of liquid insulating medium. Now you are probably aware that we have 3 types of insulating media: solid, liquid, and air. Now, since you are in the third year, I think I can safely ask one question. What is the most common insulating medium in the world?
Air.
Air.
Yes, correct. It is air. And thank God air is insulating. It is the gift of Mother Nature, because if air had not been insulating, can you think of any electrical system working? For example, you are sitting somewhere in a table or in a chair, in a wherever. Maybe next to you on the wall there is a power board. If air is not insulating, then you cannot sit there. Similarly, all the conductors that are running, the transmission line, etc., then if air is not insulating, they cannot work. So it is the gift of Mother Nature that air is insulating, and it is free. We don't pay for it. Now, when it is all that advantages we get, there is one disadvantage, of course, comes with it. Everything cannot be good, and that disadvantage is the low breakdown strength of air. Air does not have a very high breakdown strength. So, therefore, when we have to use it in a compact machine, it is not possible to use air, because then we cannot get the necessary dielectric strength or the necessary breakdown voltage. So we go for either solid insulating material or liquid insulating material. Now in this particular semester, there are 2 experiments on the high voltage laboratory side. One is on the liquid insulating material, another one on the solid insulating material. And today we are going to discuss about the liquid insulating material. By the way, in your second year, I think you might have had one subject on electrical engineering materials. Was there any course on electrical engineering materials in your second year?
Yes, sir.
Okay, so now there you might have seen that primarily the materials that we use in electrical equipment, they are divided into 3 groups. One, conductors. So without conductors, electrical system doesn't work. So we have copper, we have aluminum, etc. Okay, now I see 37 students, 37 minus 1. So 36, which should be the full house. Now again it is becoming, what happened? One student immediately left. Anyway, that's a big issue. Anyway, now, uh, so conductors are one group of material. There is a second group of material, that's the magnetic materials. Because without good magnetic materials, again, electrical machines, electrical equipment can't work. So you have the steel, you have silicon steel, you have ferrites, etc., etc. Apart from these two groups, that is conductors and magnetic materials, both of these two are primarily uh, metals. But there is a third group. That third group is the insulating materials, because without insulating materials we cannot work holes. But in this insulating material group, we have the largest variety of materials compared to conductors and the magnetic materials, which are primarily metals or the metal compounds, mostly metal oxides or some other things. The insulating materials are very broad category. It could be inorganic materials, it could be organic materials, and statistically speaking, the insulating materials that are used in practical life, 80% or more of them are organic materials. And that's a very important aspect, because that comes from a separate angle, because any organic material has a very strong aging property. That means as we use it over the years, their property goes down. So these organic materials, which are anyway 80% or more, they are organic, and therefore they have a uh, lot of what is that called, aging. Whereas the inorganic materials, for example, porcelain or where we use silica, they don't age much. So we are, much safer on that side. Now, today we are going to discuss the liquid insulating material, and this liquid insulating material also falls in that category of organic materials. They are not inorganic materials. And probably in your class you have seen, you have gone through that. Uh, this liquid insulating material, which is most commonly used in our real life, is called transformer oil. Well, it is the common name, transformer oil, because it is used, or rather, primarily oil. Earlier, it was used for transformer, but it's basically a mineral oil, and it's obtained from the fractional distillation of crude petroleum. So, we are going to discuss about this particular insulating medium today. So, there are two parts to this experiment. First part is to study the properties of this liquid insulating material. Second part is the actual experiment, that how we find out the breakdown strength of liquid insulating material. So that's today's experiment. So now I can go into the sharing of the experimental file. So now I will share. Now is it coming on your screen? Anything?
No, sir, not yet.
Not yet. Why I have done it? Okay, again, is it coming?
Yes, sir, now it's coming.
Okay, fine. Okay, now I see 36 students present at this point of time. Now I request one of you, last year I think who was coordinating? It was on your behalf. Was it Riza?
Yes, sir.
Okay, now you do immediately right now. Take the screenshot of all the present people, and later on you email it to me.
Okay, sir.
Yeah, you take the presents, people present, and take the screenshot and with the time.
Okay, sir.
Okay, good. Okay, so now let's move on to the this. Okay, now you can see it full screen.
Yes, sir.
Okay. So this is the title page, forget about it. Now there are, as I said, that we have two parts to this experiment. One, to learn about the various properties of insulating oil, and second one, to carry out the breakdown voltage test. Now in both these objectives, one thing you can see very interestingly is that we have mentioned IES. What is this IES stands for? Anyone can tell me this IES, what is it?
It's an Indian standard.
Indian standard, correct. Now, let me tell you one thing. I mean, you have to keep it in mind for the rest of your life, till you retire or till you whatever. Uh, we, the engineers, cannot work without the national or the international standards. Our engineering works, we have a boundary, and this boundary is set by always the standards. We have to comply the standards, otherwise our works are not acceptable to anybody. Now, when we are working within India, for example, I am manufacturing something, for example, you are buying something, both the parties, when we talk to each other, we have to always say that our product is as per such and such IS. And then as a customer, you will say that if your product is not as per IS such and such, I am not going to pay. So this is so important, and I think, I mean, there are certain things you should always take care. Like, say, for example, a very common object in your house, let's say the ceiling fan, or any other object you can think of. Just have a look on that machine. Ceiling fan might be difficult because on the ceiling, but there are so many other equipment, and there will be always a name tag. Without a name plate, no equipment is accepted. On that nameplate, you must see that there is something about an IS has to be written. Whoever is the manufacturer, they are bound to write it. So these are the small things you, I mean, what should I say? You make it a habit. It makes a great engineer. That's the difference between an engineer and an ordinary person. So first of all, I told you that what is an insulating oil. This is, as I said, is an organic material and obtained from fractional distillation of crude petroleum, and quite obviously, it is a complex mixture of lot of hydrocarbons. Raisa, have you taken the screenshots?
Yes, sir.
Okay, so later on you email it to me.
Okay, sir.
And as you can, I mean, I'm not going into the details of fractional distillation. That's not our job. But I have given you a photograph on the right side that you know at different stages of fractional distillation, we get different products. So we also get our transformer oil also in one of these stages. But important is, what is the use of insulating the oil? This is something I want to say that probably I am pretty sure you have been told about. The moment I ask anybody that what is the use of transformer oil, or for that matter insulated oil, for what purpose it is used, the common answer I always get is 1. Insulation, 2. Cooling medium. That's not incorrect. That's quite correct. But if I have to give marks to you, I will give you 67 out of 100. Because you have missed the third part, which is so important. And what is that third part? Third part is that this insulating oil is the diagnostic medium of the equipment. Just for example, I tell you a similar analogy that when you go to a doctor, the first thing our doctors say that you go and do this blood test. Now, I have a very common question. Say our body has so many different parts, different organs, but why blood test? I mean, most common doctors say is the blood test. There are other tests, but most common is the blood test. The reason is that blood circulates through our entire body, and therefore anything that happens anywhere in our body, that is somehow reflected in the blood in some way. That's why we do the blood test. And the same way we do the test on the insulating oil. Because insulating oil, as you can see, this is a transformer. It's not static because of the temperature difference. It circulates within the transformer. So anything that happens somewhere within the transformer, it will be reflected in the property of the transformer oil. So that's the diagnostic medium of the equipment. Now that's, I don't know why this is not written. I mean, I have not seen it in the books. I mean, most of them they write only insulation and cooling medium. But as a student of Jalapur University Electrical Engineering Department, I request you don't miss this point. That makes you different from the other students. You are our graduates. You are not a graduate of an XYZ institution. So please remember this point. What are the uses of insulating oil? These are three uses. Well, transformer oil, this I will not show you. This one is important. That first of all, you have to know how something looks. How does it look? For example, I don't know whether you go to the market or not. Right. Now, if you don't go and suddenly you are told that go and buy Hilsha fish, you will not be able to identify Hilsha fish if you go to the market. There will be so many fishes. And that seller will give you anything by the name of Hilsha fish. It is very important for all of us that at least we know how does it look, a object. How does it look? On the left, this jar with practically transparent liquid, that's actually the new transformer oil. Transformer oil is actually transparent when it is new. But then, if you normally look at transformer oil in any equipment, you can have any one of these others. These are nothing but the deterioration of transformer oil, primarily because of oxidation and generation of lot of impurities as a byproduct. And on the right, you see this is highly degraded transformer oil, almost brown color. So, I mean, this is not at all a good quality of transformer oil. So, this is a visual inspection, but then visual inspection doesn't carry any meaning to us engineers. We want quantitative data, and that quantitative data are certain properties which we test. So that's what we will study. Now there is a very common impurity that comes in the transformer oil, which is called sludge. Now, what is a sludge? Now, sludge actually, it is formed due to the, as I said, oxidation, and then because of that, some organic acids are formed because that oil, whatever its composition, that breaks down, some organic acids are formed. These
Excuse
are,
me, sir. Sir, sorry to disturb, sir. Actually, a student is not being able to get in. Like, he has been trying since 11:10.
who is it?
Himadri. He has been trying since long, sir, but he has not been able to get in. Sir, Himadri Das.
Where it is? Where is it? But I can see 36 people, that is now 35 people. But what about when you took the, that screenshot? How many people were there?
Sir,
Sir, the presentation also takes up Google
35
shows the
people.
presentation as
Yeah, that is there. I know there are two from my side, so now it is 35.
Yes, sir.
That, so I am not that digitally handicapped person. So please don't talk to me like that. I am attending the online meetings, at least 5 meetings per day. Particularly your class, I am very unhappy with your decorum. I feel that your class lacks decorum. But anyway, where is Himadri? I don't see him. Where is waiting?
Sir, he has been trying to get in for long, but he is saying that he has not been allowed to get in.
I mean, this is something very, very strange because uh, you are telling it, but whoever has come up to 11:15, I started the class. I allowed him. But where is that fellow? I can't see him. Where is he waiting? Where is it? I mean, how do I find him?
Sir, he is trying to get in. Like he said that only, that he is trying to get in, but he is not being allowed to.
Okay, you tell him to, I mean, trying, I mean, again, try once more.
Okay, sir. Okay, sir. Sir, sorry to disturb, sir.
But I still don't accept his point because I have not seen his name on my screen. He can tell anything. I don't accept it.
Okay, sir.
Now, this sludge in transformer oil, this is a byproduct of oil degradation. Now, this is a semi-solid type of um, material that don't get dissolved in oil. So what happens is that initially it's like floating in oils, and then naturally, ultimately, it settles down. But the question is, where does it settle down? There are two places that this sludge will settle down. Number one, uh, it will settle down at the bottom of the transformer. Number two, it will settle down on the windings of the transformer. Well, fine, it settles down there. But then what happens? What is the effect? The effect is that this sludge, as far as the property is concerned, is bad conductor of heat. So when it settles down on the winding, it cannot come out from the winding conductor where actually the heat is being generated because of the Joule heating to the dissipating medium, which is oil. But in between now I have sludge, and therefore heat dissipation reduces. Second, as the sludge settles down at the bottom of the transformer, this transformer cooling tube, the bottom end of the cooling tube gets choked because of the sludge. So oil circulation gets hampered, and so therefore cooling is further hampered. So there are two ways this sludge affects the transformer, and net result is that the temperature of the transformer goes up, and the so-called hotspot temperature, that means the areas or the points where the temperature is highest, that goes up, and that's not good for the transformer. And of course, presence of sludge definitely reduces the breakdown strength, and therefore if we test the oil for breakdown voltage, this will be also identified indirectly. It's not necessarily you have to go for visual examination. And this is an example of, a failure that has occurred because of sludge formation. Typically, sludge forms at the bottom side, as I said, because it will gradually settle down, mostly not on the upper side of the winding, but on the lower side. And then at some point of time, the winding gets very hot, and then there is a failure. This is very typical of typical failure of the transformer winding. Now, oil needs to be checked because there are a lot of physical and chemical conditions of the oil that we need to check because those are used for specific purposes. But if I am an engineer, if I am at the site, because we have to always think about the on-site situation, that I am at a site maybe you are the in charge there, then somebody says that this transformer or this equipment, we need to check the oil. Then we cannot go for all the physical and chemical tests. That will take a lot of time. So we need an immediate test. What is that test? This is called the breakdown voltage test. Now, typically, breakdown voltage test means we have to take some oil sample, then there are certain standard procedures, we do the test. But then big question is, how do I collect the oil? Because remember, you cannot shut down the transformer to take the oil sample. That's absolutely not possible. Shutting down a running transformer takes a lot of steps. First of all, if you shut down the transformer, the power supply of a big area will be off. We can't do that. That needs a lot of planning, that if this transformer is shut down, you have to make parallel arrangements. So we have to do it online. That means transformer will be on, still will get the oil sample. For that, all the transformer tanks, that means here you can see the transformer tank. These transformer tanks always have two oil drain valves. These are called oil drain valves. Typically one valve is at the bottom. Here when you can see the person collecting oil, there will be one at the top. These are like typical valves. If you just open the valve, you can collect the oil. So in most of the cases, we collect bottom oil sample, we collect top oil sample, and we perform the test. This is the way we collect the samples. There is one important aspect to the transformer oil. We say that it is hygroscopic in nature. Now, what is hygroscopic? Hygroscopic means that if you keep the transformer oil in air, it will absorb moisture from air. You don't have to do anything. You just keep it in air, it will absorb moisture. That's called hygroscopic. Now, then anywhere this oil comes in contact with atmospheric air, this will happen. That moisture ingress, we call it moisture ingress. For that, you have already been told, probably you know that there is something called breathing of a transformer, because when the transformer temperature goes up, when the load is high, then the current is also high, then the joule heating is also high, so the oil volume increases. And for that, to accommodate the expansion of oil, we have the transformer, what is that called? Conservators at the top. If I go back, I can show you this, where in this you can see this cylindrical object at the top. This is called the transformer conservator. So this is the tank. When it gets hot, the oil volume increases. And oil is typically, if the tank is full of oil, we cannot have air in the tank, so it is full of oil. So when it increases, it goes into the conservator. And then when the temperature goes down, when the load is less, let's say when we have 50% load, then this oil volume shrinks and oil comes from the conservator to the tank. And conservator is always kept at a higher level than the transformer tank. Not only transformer tank, there is one more thing you have to look at this diagram very importantly, that you can see these are called the transformer bushings, which are the connectors. And this bushing bottom, you can see there is a cylindrical sort of shape. That's very important because that's where the bushing is connected to the tank. The tank potential is zero. So that is also oil field. That's not air field. Air should not come here. Then there will be serious damage. And this conservator is above all of that. That means because of the hydraulic head, all the parts, including the transformer tank and then the bushing parts, they will be always filled with oil. That means there will be no air because of the hydraulic head of the conservator oil level. This is very, very important design of the transformer. But that breathing means continuously oil pushes the air out of conservator and again air comes in. But then if they come in contact with them, there will be moisture absorbed by oil. We have to protect it or prevent it, and for that we use breather, and in that breather we have to use something called silica gel, which will absorb the moisture of the atmospheric air. This is probably you have been already told in class. But the problem is that if due to some bad sealing means that the transformer tank again. Once again, this is the see this tank. If you look at the top, this is actually the tank cover. Tank cover is connected very securely with the top of the tank, and two metal surfaces, you cannot connect them without having an air gap. It is not possible, even if you make the best manufacturing practices. So, tank cover which is metal, tank top surface which is metal, we cannot put one on top of the other. So, what we'll do, there is something called gasket we put in between, which is again, by the way, an insulating material. And that gasket is actually, it can be compressed, and that's how it is sealed. But that sealing somewhere can become bad and moisture can go in. So there are many other ways that moisture can go in. And one very important thing that happens in transformer is that when the insulation, that is organic insulation, degrades, because of the degradation, one of the byproduct is water or moisture, H2O. Now, even if we do 100% active, 100% efficient sealing, we do perfect all other things, but if it is, that means H2O is generated within the transformer, I can't do anything. So, moisture is typically present in transformer oil, and over the years, it increases. Now, these water molecules are highly polar, and when electric field acts on these highly polar water molecules, they get aligned towards the higher region of higher field strength. Now, that's a very bad case because, first of all, water itself is not very, we don't water in insulation, and secondly, we find that due to the effect of field, the moisture droplets go towards the higher field strength. So that will definitely cause a breakdown. So here you can see that different types of oil samples. Left one is when water is dissolved in oil, but as you know, there is always a limit up to what level, which that saturation level. If that saturation level is crossed at a given temperature and pressure, we can also get free water in oil. I mean, this is not a joke, we get actually in a particularly degraded oil. And this is another very case where we can see emulsified water in oil. That also works. But this first one is most common, the middle one is rare, third one is also not very common. So what are the different impurities in transformer oil? As I already said, most important is sludge, second is water or H2O, but then there could be others, like as I said, there will be acids, there could be fibrous materials, because these fibers come out of the paper or it can come out of some of the other insulating materials. And again, the same thing happens that when these sort of impurities are free to move, they will always align along the lines of force, and therefore they will cause disruptive discharge. So here you can see that impurities in oil, one is lighter than oil, so they will come on the top, then there will be some at the bottom. But then we can do what is called the processing And in very common language, if you talk to any power engineer, they will say filtering. Filtering of oil. Now, this I have already discussed. Yeah, this oil aging, that rate, that is also affected by some of the parameters. That means if the oil has, it comes in contact with air, then atmospheric oxygen causes oxidation, which acts as one of the agents of aging. Second most important agent, in fact, I would say first most important agent of aging is temperature. Temperature within an equipment continuously goes up and comes down because of the change in the loads. So that plays a havoc with the insulation aging. Then there are chemical effects, and this is being affected by the presence of metals in the equipment. So we have copper, we have steel, sometimes we have some other metals, so they also act as catalysts. And finally, one other agent that affects is the electric field intensity. Depending on what is the value of electric field intensity, the aging also gets either accelerated or decelerated. If the field is high, we get accelerated aging. So here you can see again another view of different types of aged oil. As you can see, new oil is transparent. Gradually, its color is darkening. Now, what is called reprocessing of transformer oil, which I said that in very common parlance, it is called filtering of transformer oil. Well, first of all, we have to understand that there are different types of impurities. We have moisture, we have acids, we have some other organic volatile materials, and we have sludge and other some solid or such materials. So how do we process? Typically what we do, and once again you remember this is done online, we don't shut down the transformer. Typically we have the equipment, then they are connected to the top and the bottom oil drain hull. We have the pumps. So we pump the oil from the bottom, then it is kept in a vessel, and first we want to remove moisture. How can I do that? Very simple. I heat the oil at 100 degrees centigrade. So naturally the water will vaporize. But there is a problem. If you remember, there is a categorization of insulating materials, that class Y, class A, etc. probably you have studied. Transformer oil belongs to class Y, which is the lowest category of, or the lowest class of insulation. And this class of insulation, these classes are based on the highest temperature at which it can work safely. And transformer oil, class Y, highest temperature is 90 degrees. So you cannot heat transformer oil at a temperature higher than 90 degrees. Then transformer oil itself will get damaged. And how can I remove moisture? Then you have to use your +2 level physics, that the boiling point of something is dependent on the pressures. And boiling point reduces if pressure is decreased. So we heat the oil not at the atmospheric pressure but at a reduced pressure. So we use a vacuum chamber, pump the oil from the transformer, put it in the vacuum chamber, heat it at a temperature not exceeding 90 degrees and remove the moisture. And also other volatile organic materials naturally get separated from oil. Then we have to remove sludge and others. So we pass this heated oil after the vacuum chamber through a series of graded filter papers. These filter papers have graded porosity and they will remove the solid impurities. Now, this is not done in one run. That means one time I circulate the oil. No, doesn't happen so quickly. In a very big transformer, this treatment process goes on up to even 12 hours. After that, we can get a good quality. So what we do is when this process goes on, after some hours, we take a sample, do the breakdown voltage test and see whether the property has improved. If it has not improved, we keep on running the treatment process till we get the proper breakdown voltage. Sometimes we use adsorbents that absorb these absorbents can take out the moisture and other polar impurities, but not always it is used. Sometimes oxidation inhibitors are used, but nowadays in IS 335 they recommend, or rather they does not recommend the use of antioxidant because they have some other uh, bad effects. So this is what the machine looks like, the reprocessing unit. So you can see there is a pump, there is a vacuum chamber here, then control valves, etc., etc. This is typically uh, mounted on a vehicle. So if you want to process the oil at any particular substation which may not be in a city, so what we do is we drive this vehicle there, connect it, run the entire process, and the vehicle comes back. This is typically it is done. This is the top page of IS-335, just for your information. It defines various terminologies, properties, etc. of the oil. Now, some of the properties I'm just telling. One I have already discussed, that appearance. It comes under the segment physical property, and there is a process that how we have to test it. So you can see here that oil sample in transmitted light under a thickness of approximately 10 centimeter and at ambient temperature. That should be the visual inspection. That means we just don't go and look at it. There are certain ways to look at it. And if it is a good oil, it should be clear. Now, one very important point is core point. There are a lot of other properties, everything cannot be discussed, but this core point I want to discuss. You know that insulating oil is supposed to circulate in transformer. But as the temperature goes down, the viscosity increases. And if a temperature which is specifying that temperature where the oil will just flow or conversely just ceases to flow. Then flash is the other side. That means when we are increasing the temperature, there is a danger of fire. Now, typically we make a mistake between flash point and the fire point. Flash point, rather fire point is that temperature where oil catches fire spontaneously, whereas flash point is not there. Flash point is that temperature which is under normal atmospheric pressure, that is 1 atmospheric pressure. An ignition source is required. That means somewhere a flame will be required, and the oil does not catch fire. It is the oil vapor that catches fire. Typically, that temperature is 135 degrees centigrade. Now you can clearly see that if flash point is 135 degrees centigrade, then we have to always think that where this transformer will be used or equipment will be used. If it is Rajasthan, then our ambient temperature could be anything around for 50 degrees centigrade. Every equipment is designed for a temperature rise. All equipment, irrespective of whether it is electrical, electronic, computer, whatever, it has a design temperature rise. Normally, these power equipments have a temperature rise of 65 degrees centigrade. So if the ambient temperature is 50 degree, the temperature rise is 65 degrees centigrade, so temperature is around 115 degrees centigrade, which is still below the flash point. That's, I mean, these are, all these temperatures have been defined from the safe operation of the equipment. Then acidity, as I said, organic acids are generated in transformer oil because of degradation. And these organic acids, they attack the solid insulation, that means paper, and damage it. So we don't want large amount of acids. Typically, this is always measured by titration. So you can see here the unit is potassium hydroxide per gram of oil. The maximum allowable value is 0.01 milligram, which means very, very low amount of acid is permissible, otherwise it will ruin a transformer. Tan delta or dielectric dissipation factor. I hope you remember what is the tan delta. Ideally, any insulating material is represented by a capacitor. That means the current through an insulating material will lead the voltage by 90 degrees, and therefore there will be no power loss because cos 90 will be 0. But that never happens. In a practical life, no material this will happen. So there will be some amount of power loss in an insulating material. By the way, it is not Joule heating. This is called dielectric heating, which is a way of heating a material. The same dielectric heating happens probably in your home if you have a microwave oven. Now, in any practical insulating material, this angle is not 90 degrees because of the dielectric losses. So we have a small deviation delta. We can prove that the dielectric losses are proportional to tan of delta, and therefore this tan delta is known as dielectric dissipation factor. Ideally, it should be 0. If delta is 0, tan delta is 0. But it is not 0, so maximum value you can see here is 0.005 at 90 degrees centigrade. These are, this tan delta always varies with temperature, so it is given as a function of temperature. And the very importantly, breakdown voltage. It is typically 30 kV to 70 kV. That means if it is below 30 kV, it is not a good oil. Typically, if it is around 50, we say it is acceptable. 70 is too good. Now, I have to tell you, or rather ask you now, that there is a difference between breakdown voltage and breakdown strength. Breakdown strength and breakdown voltage, I have to tell you the difference. What is that? See, if I have a sample, let's forget about oil. Let's look at, say, paper. I have one sheet of paper which is 1 millimeter thick. If I test the breakdown voltage, let's say I get 10 kV. If I take 2 sheets of paper, the breakdown voltage may be 18 kV. So breakdown voltage depends on the sample, its thickness. Whereas breakdown strength is an intrinsic property. It doesn't depend on the sample. It's a property of the material. So therefore, how do we represent it? We represent it as breakdown voltage per unit length. Now, the moment we say breakdown voltage per unit length, its unit does not remain kV. It becomes kV per millimeter, kV per meter, whatever. But moment it is voltage per unit length, that quantity is not electric potential. Voltage per unit length is electric field intensity. So breakdown strength actually tells us that what is the maximum electric field intensity that a material can withstand. Every material has a value of maximum field intensity which it can withstand. That's a property of a material irrespective of the sample size. But here you can see we are measuring breakdown voltage. So you can always ask why we are measuring breakdown voltage, why not breakdown strength? The answer is very simple, that we are using a very standardized setup which is given in IS 6792. And if I use that standard set, I think you have to tell your friends to mute. So we have a very standardized test cell which is used, and if I use the standardized test cell as defined in IS 6792, find out whose mic is giving the noise.
udah nami time ko benda tali dudi bana iya be udah ar duga nami da
Find out whose mic is giving all this. So this standardized test cells, this is the diagram of the test apparatus where you can see that we have this is a standardized test cell where you can see the electrodes are spherical in shape. This So this spherical electrode, the diameter can be anything between 12.5 millimeter to 13 millimeter. The gap distance is very important. It should be 2.5 millimeter. There, that has to be maintained. So now, if I use this test setup, then this gap is fixed. Therefore, per unit length, you can see it is fixed. That's why we are testing breakdown voltage, not. So it is indirectly we are testing breakdown strength. The volume of oil is also fixed. As you can clearly see, the total volume as the glass vessel, every dimension is fixed. This is as per our India standard. So the volume of this cell could be anything between 350 milliliter to 600 milliliter. So we take that sort of oil and pour it into it. And at the bottom, of course, the color is not so good of the presentation. The gap between the cells, if it is, it is 2.5 millimeter, the tolerance is very, very low. It is 0.05 millimeter plus minus. So it has to be set very accurately. This is the schematic of the oil test setup that we use. What is that? Typically, see, look at here. We have a variac. Look, if you can see my mouse moving here, this is a motorized variac. Then output of the variac, the input of the variac is very normal 230 volt supply. Output is taken, it goes through an overcurrent relay in series with a line, because if the transformer oil fails, at that point current increases, the relay senses it, and it trips its contact at the bottom, which is the control circuit. That OCR stands for overcurrent relay at the bottom. Then after that, we have the main contact, but it is not electrically operated. It is operated by a contactor coil shown at the bottom. So when the contactor coil gets the supply, the main contact closes. When the contactor oil gets disconnected, the main contact opens. We are measuring the voltage at the input side, and then from the turns ratio of this transformer, we can get what is the high voltage. Otherwise, putting an high voltage meter here is very, very expensive and not so easy on the high voltage output side. This transformer is a center tap tapped. So both the spheres are at equal voltage, but one is at the positive, the other is at the negative. So if we apply 60 kV, then the top one will be plus 30, the bottom one will be minus 30. This is typically used because then we can use the same supply for some other purposes. That means if I want any test just for 30 and R, then we can use one terminal of the setup and the center tap, we can use 30 kV and R. So we can have a lot of combinations of voltages. And how this control circuit works, these are all done through contactors. Our primary objective is to either energize or de-energize the contactor coil. Now, the on switch is in series. It is typically, we call it normally off, a no contact, normally off. When you want to switch on, we press the contact and the circuit closes. Then there will be an off switch in series. It is normally closed, we call it NC. So normally the circuit is closed. When you want to switch off, we press it, the circuit gets disconnected. Then we have the overcurrent relay contact that is operated by the relay in the main circuit. Normally it is again closed. It is an NC contact. When the current is high, the relay senses it. The normally closed contact opens, the circuit gets disconnected. But there are two safety features here. I will show you the setup. It has a door through which this test cell has to be inserted. But for high voltage test, we have to take all safety measures. So that top cover has to be closed. So there are two, we say it is the door contacts. These are typically the limit switches. Limit switches mean when something moves, when it reaches at a certain limit, either a contact is on or a contact is off. The most common example which you might have seen in your home, or maybe you have seen, you have not noticed, that is your refrigerator. Whenever you open your refrigerator, there is a light inside which is switched on. But you don't do anything, it is automatic. But how it is done? Because there is a switch with the door. It is when you close the door, the switch is off. When you open the door, the switch gets on. These are called the limit switches. So this door has two limit switches. When the door is closed, the contacts are closed. When the door is open, the contact is open. So when I want to switch on this setup, I want that this contactor coil should be switched on, or it should be energized. So if the door is closed, the door contacts are closed. The OCR is normally closed, it will remain closed. Off is normally closed, it will remain closed. Then I press the on, so it will be closed. But still you can see that there is an open circuit here. As you can see, my mouse is moving between off and on, there is an open circuit. How does this get closed? This gets closed by another limit switch, which is connected to the variac. When the variac comes down to the zero position, then this limit switch, where you can see here zero switch, that get closed. So then this open circuit position between off and on, it will get connected through this zero switch. So you can see here off, then line goes up, zero switch, and it comes back to on. So when the variac is in zero position, you press the on button, the contactor coil gets energized. Or in other words, if you don't bring the variac to zero position, you cannot switch the setup on. This is another very important safety feature that we don't switch on the circuit with the voltage on. We bring it down to zero, switch it on, then increase the voltage. But moment you increase the voltage, this limit switch, which is the zero switch, it will again be disconnected. So the contactor coil will get disconnected. That cannot happen, then our main circuit will be off. So there is an auxiliary contact of this contactor coil. So when the contactor coil gets energized by pressing the on switch, immediately the auxiliary contact is closed. So you can see that from the off position, the circuit is now maintained through the auxiliary contact. And it bypasses the on switch also. That means we can press the on button, then we don't need to keep it pressed for the entire duration. Otherwise, it is not possible manually. So this on switch and the zero switch, they are needed only for switching on the setup. The rest of the thing is through the auxiliary contact. But the moment it switches off, that means there is a breakdown, the overcurrent relay senses it, the OCR switch is off, contactor coil de-energized. The moment it is de-energized, the main contact opens, the auxiliary contact also opens. So if you have to switch on again, you have to bring the variac to zero position again. This is how it all works. This I have already explained. This is the motorized variac with zero switch. I have already explained the overcurrent relay. Then I have explained the main contact. I have explained the center tap transformer. I have explained the auxiliary contact, door contact, and this overcurrent relay contact. Now, this is what I have not explained. This is that, say for example, I am doing the test. I have increased the voltage and the oil breaks down and the setup trips because the overcurrent relay trips its OCR contact. Now somehow I have missed the reading. Then how do I know that at what voltage the breakdown has occurred? Should I have to do it once again? That's why there is an arrangement made that if you don't move the variac, that means the input is still there, so the output voltage of the variac is still there. That's not zero. So there is a memory switch. If you now it is normally open, so you make it on manually. Then you can measure what is the voltage at the variac output. That means you know at what voltage the breakdown has taken place. So this is used only when we have missed the voltage at which the breakdown has taken place. The voltmeter is a very normal AC voltmeter, so we can use any standard voltmeter. This I will show you that our high voltage lab has developed a demonstration app. It is not yet complete, but I will show you. That I will not do now. This I will. Now this is the photograph of the entire setup. This is the oil test setup. As I said, there is a top door. This is the door. With this round button, we open the top door and then we insert the test cell. This test cell is as per Indian standards. These are the control buttons. How do we do it? First procedure is important. We pour the oil and then we keep it for some time so that when you pour the oil, there may be a little bit of oil, air bubbles, etc. So you give time for the oil to settle down. Then the oil filled cell, we put it in the test cell box, close the door, then we switch on the HV. Voltage is slowly increased at a steady rate. This is very important. We should not abruptly increase the voltage because dV/dt, rate of change of voltage, dV/dt plays a big role in breakdown. When breakdown occurs, the OCR trips the supply. This transient breakdown I will explain. But although there could be these transient readings, but we have to ignore it. Now here is it, you know, test cell, where you can see this is not an entire spherical electrode, it's an hemispherical electrode. So this is the live side, this is the earth side, but in our test setup, both are live. One is positive, the other is negative. And we have a 2.5 millimeter gap. The breakdown takes place between the two electrodes. Now, transient breakdown, that's an important aspect. If the oil has some impurity, as I have explained, what are the impurities? If it is a real life oil, there will be always some impurity. So what happens? The moment I apply the voltage, that means electric field is generated. And then the impurities, they are being pulled by the electric field in the region of highest field. That means between the two spheres here. It's a blown up diagram. So some impurities have come here. And because of these impurities, now there will be a breakdown. But you can always argue why it is transient, why not permanent breakdown. The answer is very simple, that when there is a transient breakdown, the temperature goes up, and because of the high temperature of that spark, these impurities either get vaporized or they get removed from this point. So that there is no permanent breakdown, it's only a transient breakdown. But as per Indian standards, these transient breakdowns we have to ignore. Rules to follow, this is very important. Again, as per Indian standards, as I said, that we have to increase the voltage at a steady, uniform rate. But then you can ask me, what is that rate? Well, answer is given in IS. That is 2 kV per second plus minus 0.2 kV. So it could be 1.8 kV or 2.2 kV, starting from 0 up to the breakdown. The next question you can ask me, how many times I do the test? The answer is IS says 6 times. And a third point is already stated, the transient breakdown, if it happens, please ignore, only the final breakdown is recorded. And when we do a breakdown test, once a breakdown occurs, we cannot test immediately again. We have to give a pause of at least 2 minutes. We have to find out whether any gas bubble has been produced due to that breakdown. If it is there, a glass stirrer is used. With the help of glass stirrer, we remove all the gas bubbles, and then after 2 minutes, we can do the second run. So in this way, we do 6 tests and we take the average value as the reading. So this is how we have to prepare the result table. So 6 runs, every time we start from 0, go up to the breakdown voltage, note down the values, these are all in kV RMS, then we take the mean breakdown voltage, and that is our final one. Inference, this is very important. A good oil should have around 40 kV per RMS. As it comes nearer to 30 kV RMS, means the oil quality is deteriorating. If it goes below 30 kV, then that means that treatment of oil is required. And as I said, that when you do the treatment, we continuously check the breakdown voltage until we get at least 50 kV. Otherwise, treatment is not closed. It is continued till we get at least 50 kV, preferably 60 kV RMS. That means after every half an hour, we take oil sample and test to get the breakdown voltage. Now, this is so far as this presentation is concerned. I am going to show you some videos actually taken in our high voltage lab. What is that? First, I will show you some transient breakdown. Look at it. See, voltage is increasing. Now, again, I repeat it. Probably you might have missed it. See, this hand finger means that we are switching on. And when we are switching on, the meter, if you look at it, this indicator increases. As I said, it's a very ordinary indicator, analog type, not even a digital type. So initially there will be a small discharge, that's called the transient discharge. Finally there will be the complete breakdown. So again, look at it. Yeah, I think now you can see it. Yeah, here, that's the transient breakdown. But there is no complete breakdown because the voltage is still increasing. See, voltage is still increasing. See, now the complete breakdown has taken place, and we note down this voltage, this final value. And how do we perform the test? So then go back to another video. So see, we switch on first the low voltage, then the high voltage, then the main. Now that's the electric contactor is. Now the green button is pressed, and now the voltage will increase. You look at the indicator, the voltage is increasing, and breakdown occurs, and the indicator has come down. That's what I said. How do I know the voltage? So memory switch is pressed. I immediately know what is the voltage because I have not brought it down to zero. So we bring it down to zero again, and then we restart. So I again replay the videos. So see, first we switch on, first low voltage, high voltage, then the main circuit. Now we will increase the voltage. It is increasing. And now the breakdown, but indicator has come down, so we press the memory switch and note down at what voltage breakdown takes place. Then we bring it down to zero again. Then we bring it down to zero. And after that, you have to open this top cover, take out this one. If there is any gas bubble, use the stirrer, remove gas bubbles, and then you do the test again after 2 minutes. In this way, 6 readings have to be taken. So this is another video, and there is a software demo also, although not very smart, but quite okay. Let me show you that one. This is actually called Virtual Lab. Yeah, so this is a Virtual Lab software. So there are different experiments. I click on the electric strength test on insulating oil. So first so there are different tabs on the four tabs are there. First one is objective and circuit diagram. So the students can learn from this tab. Setup and procedure. Here some of the things are missing, even it's not complete. But then we go to the laboratory room. This is a good one. So this is a laboratory room where you can see the photograph of the test cell. This is the test cell, and this is the entire test setup. There is something called setting here. The 3D view option was there, but it is not working as yet. So gap setting 2.5. Then I say accept, back to test. Then there is a variac button here. You can see now it is off. So I click the red button. Now it is on, and this powers up. This is, you can see now this is going. So what I can do now with the help of the mouse, I can now turn this knob, and the voltage will increase, and there is an indication. Now you can see slowly the voltage is increasing. I have to move the mouse slowly, and voltage is increasing. Breakdown has occurred. So breakdown voltage 40. Then we can go to the test result section, and we can see that for a breakdown voltage, this is 2.5, breakdown voltage 40. So what we can go back back to this laboratory room. Then again I switch on. Now the voltage is 0. So again I move my mouse gradually. I can get another reading, and then I can see what is the test result. So this is how this demo has been, this virtual demo has been prepared through a virtual laboratory type of software. Unfortunately, I cannot, give it online because it's not foolproof. It is still there are a lot of bugs in it. But anyway, I just showed you that this is how we are doing. We can exit here. Good. So now that's what I think is for my that is this. Here. So now, two things. First thing is, after this class, you will get an email from my side wherein instruction will be given for submitting the laboratory report. You will get 7 days time. So all instructions are given on this in this mail. Go through it carefully, then prepare the laboratory report, prepare the PDF file, then mail it back within the stipulated timeline. Now that's over from my side. Now it is from your side. Anybody has any question? Any question? Well, if there is no question, then I will close the class and then you can log off.